Algebra 2 Regents, sample question number 11. Algebraically prove that the difference of the squares of any two consecutive integers is an odd integer. This is a really challenging proof, especially because we didn't talk a lot about consecutive integers, and we haven't done a lot of proofs in Algebra 2 in general. You did a lot of proofs in geometry, but they're not really algebraic proofs. So this is a challenge here. So let me show you how to do this. So first of all, consecutive integers. Consecutive integers go like 1, 2, 3, 4, 5. It's simply the next number. It'd be different if it said consecutive even integers or consecutive odd integers. So what we're going to do is we're going to let x equal the first integer. And so then the next consecutive integer would be x plus 1. Again, if it had said consecutive even integers, then x could still be the first, but then we would have x plus 2 as the second. And also, if it said consecutive odd integers, you can still let x be the first one. And x plus 2 would still be the second, because odd integers are 2 away from each other, just as even integers are. So if you get a consecutive integers part, you have x, x plus 1, and then the third would be x plus 2. But if it says even or odd, which this one doesn't, but if it did, x would be the first, x plus 2 would be the second, and x plus 4 would be the third. Again, same for even and odd, because just regardless of where we start, the next one is 2 away. But because it's just simply consecutive integers, x is the first integer, and x plus 1 is the second consecutive integer. All right, so prove that the difference of the squares, so difference we know means subtraction and squares means squared. So the difference of the squares of any two consecutive integers is an odd integer. So the way you do difference between two numbers is you do second minus first. You do, larger minus smaller. And so the second integer here is x plus 1, and the first integer is x. So it's going to be x plus 1 minus x, but it's not just the difference of any two consecutive integers. It's the difference of the squares of any two consecutive integers. So we need to square these. Because the difference of consecutive integers, that's just, a number minus the one before it. But the difference of the squares of these, we have to square them. And we want to prove that this is always going to be an odd integer, the difference of the squares. So x is the first, x plus 1 is the second. If I square them and subtract them, I need to prove that it's odd. But what happens to this? Well, when I square this, x plus 1 squared, I get x squared plus 2x plus 1. Remember that binomial squared we see often. You can square the front times each other, doubled. Square the back. Don't forget to double it when you times each other. Or you could do x plus 1 times x plus 1 and distribute. That's fine too. But it's going to be a trinomial. Minus x squared. And this result comes out to equal 2x plus 1. Because we have an x squared and a minus x squared that combine to 0. So are we done? Well, we just proved that the difference of the squares of two consecutive integers is 2x plus 1. Does that prove that this is odd? Is this always odd? Well, if x equals really any integer, I shouldn't say if, this proves odd because 2x is going to equal an even integer. Because regardless of what x is, if x is even or odd, if you multiply it by 2, it becomes even. Think about it. 2 times an even integer, like 4, 6, or 8, gives you another even. 2 times 4 is 8. 2 times 6 is 12, another even integer. But if you did 2 times an odd number, like 2 times 1, 2 times 3, 2 times 5, 2 times 3 is 6, 2 times 5 is 10, 2 times 7 is 14. So if you double any number, you get an even integer. So 2x is an even integer. Therefore, 2x plus 1 must equal an odd integer, because an even plus 1 is odd. And that's it. That's the proof. And so it's actually a pretty quick problem, but it's a very weird problem, and a little bit different than what we're used to here in this course. So by proving the difference of the squares of any two consecutive integers, again, if this is my first, this would be the next consecutive integer in line, one more than the previous. And if I square them and subtract them, I get 2x plus 1. And that has to be odd because this is even, and if you take an even number and add 1, it becomes an odd integer. And you could certainly, write that out a little bit. more in sentences here, but this is really all that you need. So that's sample number 11. Let's take a look at number 12 too while we're at it. So rewrite the expression 4x squared plus 5x squared minus 5 parentheses 4x squared plus 5x minus 6 as a product of four linear factors. All right, there's two ways to do this question, and there's a very long way and a very short way. Um, Let me show you the shorter. The shorter way is recognizing relationships, recognizing patterns. And this is not an easy thing to do here, but notice that this is the same thing here. And so let's pretend for a second that that was just x. Like, let's pretend this whole thing was just x. What would we have? We would have, or let's pretend it's a. Let's say this equals a. We would have a squared minus 5a minus 6. And factoring that is simple. And if I want to write something as linear factors, that's what we're doing. You know, we're trying to get it to x plus 3 parentheses, x minus 2 parentheses, you know, stuff like that. So if you recognize something like this, well, if that's being squared and then minus something times it, just pretend that's a for now and factor it as a. And this is just a very basic trinomial factoring here. You know, what multiplies to negative 6 adds to negative 5. That would be a minus 6 and a plus 1. And multiply negative 6 adds to negative 5. But see, the issue is it's not a. A is 4x squared plus 5x. So what I really have here is 4x squared plus 5x minus 6 and 4x squared plus 5x plus 1. So the a plus 1 is the 4x squared plus 5x plus 1. And the a minus 6 is the 4x squared plus 5x minus 6. And now I need to factor both of these. So this is AC factoring. AC factoring to the extreme here because I got to do it twice. But the way AC factoring works is we're going to split this middle term. And let me just kind of split these for now into two terms that multiply to a times c. And I can write that over on the side. AC is negative 24x squared. First term times last term. And so what multiplies to that and adds to 5? Let's see, I think negative 8x and positive 3x. Oh, I got the signs wrong. Let me switch that up. It's positive 8x because I got to add to 5 and a negative 3x. That gives me 5 and multiplies to negative 24. Bring down the front, bring down the back, slice it in half. GCF the front, I could take out 4x, left with x plus 2. Over here I could take out a negative 3, left with x plus 2. Group my terms together. You group the GCFs together to be 4x minus 3 and x plus 2. All right, now I'm going to do the same thing over here. Split this one up. This time AC is simply first times last is 4x squared. So there's not a lot of options here. It's either 2x and 2x or 4x and 1. And since I needed to add to 5, it's going to be 4x and 1x. And then bring down the plus 1, the 4x squared. Slice it in half. GCF both sides. You get 4x left with x plus 1. When there's nothing to take out, you still want to take out at least a 1, and I'm left with x plus 1, because whatever I take out, it's got to get grouped with the GCF over here. So if there's nothing to take out a positive 1 or a negative 1, and we get 4x plus 1 and x plus 1. And that's it. Those are the answers. Now I want to maybe you know, put these next to each other because that's oh, sorry, I want to move this line out of here. You always want to have the groups of parentheses right up against each other. But that's basically it. Let me draw this split back in the middle here just to keep that there. But challenging question, because if you didn't recognize to like factor it without that and then bring it back in, it's a tough question. What we could have done was actually what I think a lot of students would do, and it would take a lot longer, is square this, distribute this, and you get a really long, tough looking thing. I actually think I have the workout that it would end up being 16x to the fourth plus 40x to the third plus 5x squared minus 25x minus 6, and then factor that. But that's really hard to factor. So what I would probably do to factor that if I really got stuck is maybe look in my calculator, see if I could find a root. And if you looked on the calculator, you would find, x equals -1 as one of your answers, and then you can know that it must be x plus 1. You could divide it out to make it a little bit simpler, and then see if I could factor that. If not, look for another simple root, which you could find this one there, and divide that out, see if you could factor that. But it would be tough going another way, but it definitely could be done with a type of calculator type thing. But knowing to not square it and distribute to go this way is recognizing the pattern that something squared minus 5 times something minus 6 can be factored, and then I could bring that something back in. Tough question for sure, but that's what this course is. All right, see ya.